So far we've learned about different quadrilaterals, and we now move on to another theorem which is closely related to quadrilaterals, but then it sort of stands alone as well, because the first part of the theorem actually concerns a triangle. So the given conditions, if I precisely summarize them in one statement, we have two midpoints in a triangle. So when you see this particular condition, please recognize that it is highly possible we are going to use the midpoint theorem. What do you see here? The two triangles. Are they similar? What's the reason? Ratio of two sides included angle, it gives a pair of similar triangles. But then, this theorem predates the theory of similar triangles. Historically, we discovered this first, because given this condition, you will find out that, first of all, the two sides MN and BC are parallel. And secondly, MN to BC has a 1:2 ratio. All right, so that's the midpoint theorem. So let's try to apply it. If we join two midpoints in a triangle, there are many ways to state midpoints, but as long as they have the same length, AD equals DB, then it's a midpoint. So in example 21, we state that this is the midpoint. AD equals DB and AE equals EC. So we fulfill the two midpoint conditions. And then you can freely say that DE is half of BC and DE parallel BC, just as we said earlier. And these are both denoted as midpoint theorem. Given a lot of midpoints, two midpoints, you have midpoint theorem. And then you can use this result to work on different aspects of the diagram. For example, to find x, you just move the angle 72 degrees to above. And then using angle sum of triangle, you can find x as 69 degrees. Also, we want the length of DE. The question asks two things, and the length of DE is 5 cm. Example 22, similarly, the midpoints are not marked on the diagram, but still you can see midpoint theorem in practice, because you have D, E, G, F are midpoints. So you may directly write the midpoints, and to denote midpoints is probably easiest to rewrite in the format that I just gave you. CF equals FD and CG equals GE. Can you see that this is in one triangle? We have two midpoints. And if that's the case, then our conclusion is that the two lines are parallel. FG parallel DE. We don't know whether this has to be used, so it's probably good to write that down first. DE equals 2 times of FG, midpoint theorem. You are allowed to write the theorem this way so as to save time. Okay, so DE is 6 cm. Also, because AD equals DB and AE equals EC, these are also given midpoints. D and E are the midpoints of AB and AC respectively. So DE is parallel to BC, and BC equals 2 times of DE. This is the midpoint theorem. And therefore, the length is 12 cm. So just tell me the answer. If angle GFC equals 40 degrees, then what is angle DCB? So of course it's 40 degrees because FG parallel DE, DE parallel BC means that all 3 lines are parallel. So they are just alternate angles, FG parallel BC. All right? And this is an extra part in case people don't know that. Anyway, the midpoint theorem is now applied when we have a triangle and we have 2 midpoints. Can you try practice 22 to see whether you understand the application of this theorem? One thing you may want to ask is that, are we required to write both results? You may just write the parallel or just write the 2 times, but it doesn't take up too much time and it saves you from rewriting the step later, so I usually write both, all right? Practice 22, you can spot that there are 2 triangles, and in each of those larger triangles, you can apply the midpoint theorem because, for example, in the right-hand triangle, EG equals GD and EC equals CF. You must state both conditions in order to apply GC equals half of DF and GC parallel DF by midpoint theorem. So this is the whole set that must be written in use of the point theorem. And therefore, angle GCE equals angle DFE, corresponding angles of your parallel lines. And X is 75 degrees. Y, if you name the triangle, because there are now 2 copies of 75 degrees, you are required to name the triangle in applying angle sum of triangle. But then if you name the triangle or name all angles, you can easily conclude Y is 45 degrees. And finally, you need DF. So you get AC is 20. Sorry, AC is 20 cm, so GC is half of AC, is 10 cm. Therefore, DF is 2 GC. You may say it's proved, and therefore 20 cm. You may rewrite this in different ways. So our first extra question here is AB 2 times of GE? Just a yes/no question, quick one. Why is it yes? Okay, who say yes? Who say no? Who is not sure? Not sure, what do you mean by not sure? You don't know. 點解覺得佢係啊？咩叫 Mid Point Theorem 啊？如果你講得出個但係，就已經差唔多答完條問題㗎啦。答案係 no 嘅，我 may not be 啦。點解啊？你需要 BE 等於 EC 呢個 condition 啊。If BE different from EC, actually this is the converse of Mid Point Theorem, but this is also true. So AB is not 2GE because for Mid Point Theorem you need two conditions instead of just one. You have one midpoint here, but the E is not a midpoint, so you shouldn't apply Mid Point Theorem directly. 得唔得？所以今日重點 Mid Point Theorem 你要喺個生命裏有兩個 midpoint 先好用 Mid Point Theorem， 得唔得 ？So how about this? If you immediately spot the answer, you don't need to write it down. Yes. 如果你即刻睇到，你就調翻轉唔使寫低。但係如果你而家早到而家呢一刻都未睇到咧，1比2係啱嘅。But why？ 即係講得出1比2，實知道點解㗎啦。Centroid. Okay, this is a centroid. If you join the line differently, you can compare with the original diagram we have here. If we join MN, then the relevant theorem is Mid Point Theorem, and your main conclusion is MN is half of BC. This diagram is still the same, but if we join different lines, then we can consider MD and DC, and the ratio would be 1 to 2 because of centroid properties. Okay? So compare these two. Sometimes people are confused about this, but Mid Point Theorem applies when you join up the midpoints. Okay, next. How about this? ABC is a quadrilateral, and then it's given that PQRS are the midpoints of the 4 lines respectively. I want you to prove that the shape in the middle is actually a parallelogram. It's just a random quadrilateral. By the way, this is a correctly set question. So based on the conditions, I'm saying these two are equal, these two are equal, these two are equal, and these two are equal. Can you see what I see? Why do we put it in this chapter, or in this section? What do we need for Mid Point Theorem? Triangle and 2 midpoints. You have no triangle in this diagram. So why not create one? Join AC. Now what do you see? In the top triangle, ABC, we have BP equals PA, and BQ equals QC. Well, at the moment, you may not see why this is useful, but you can still conclude PQ parallel AC and PQ is half of AC by Mid Point Theorem. Not quite relevant, right? Can you guess what I'm going to do next? No, I'm not going to join the other diagonal. It's going to be way too confusing. 無端端先點解要證明 PQ 係 AC 嘅一半同埋 PQ 平衡 AC 咧？你睇唔睇到需要睇嘅嘢咧？睇到就寫埋佢。So of course, by the symmetry, you should already notice that dr equals rc and ds equals sa. Therefore, rs is another line that is parallel to AC and half of AC by Mid Point Theorem. How does that help us? Therefore, both lines are parallel to AC. They are parallel. Both lines are equal to half of AC, so they are equal. Then the natural conclusion is that PQRS is, I want to write this as SR because that's the order. They are parallel. PQRS is a parallelogram by two sides equal and parallel. So we borrowed the line AC, we compare with AC to get this result. Is that clear? Okay, so you may now work on practice 23. 好，有同學問咩叫做我 conclusion 要做乜嘢咧？有同學咧就話其實係唔係要證明佢哋全部相等？咁其實就唔係嘅。Bisect each other just means I need PO equals PR and SO equals OQ, and then they are the bisector of each other. So this is the final conclusion we need. Is that clear? Okay, first of all, let me outline the solution. To solve this, one exciting way is to join SP, DB, and RQ. And then you can prove that SP equals half of DB and SP parallel DB, just as in the example above. So similarly, and then RQ also has the same property. So SP equals RQ and SP parallel RQ. In other words, PQRS is a parallelogram by two sides equal and parallel. And therefore, the next line is still true because that's a property of parallelogram. So, two questions for you to think about. Some student claims that because DO equals OB, therefore SP equals half of DB equals DO. True or false? Okay. Secondly, is PQRS a rectangle? It looks like one. Okay, go home and think about these two. the hint is that they are closely related to the way we solve this question as well. Any questions about this? Okay, first of all, please help me check the multiple choice questions. The answer should be C, B, D, C, B, A. So each of them is worth 2 marks. Sometimes we do make mistakes in this type of markings. And now the numerical answers. For question 1 is x greater than minus 19, so 19. Question 2, n is more than 72, therefore 65. Why? Because 17 still integer. Okay, and then for question 3b, the answer is $31250. Question 4, you should get 20% for part A, and for part B, 1 is 257989, B2 31944, which is greater than 30,000. And then for the challenging, the answer is $30,000. I'll upload the full solution onto Google Classroom, so you may check it out later. Just one particular comment here. For the last question, some of you are confused whether this is correct or not. Mr. Yuen 話上下調轉啱嘅喎，幾時會錯，幾時會啱啊？ Only if both positive or both negative 先要轉 sign。如果你一正一負就唔使轉 sign 㗎啦。例如一個係1，一個係-2，正嗰個永遠仍然大過負嗰個嘅。Okay, so that's the test results.